This lecture should tell you two of the heuristics that you can use to choose a good machine learning classifier. In previous lectures, we've seen how we can evaluate machine learning models using metrics such as accuracy, precision, and recall. We've also seen the trade off that exists between precision and recall, depending on how conservative your decision threshold is for the probability scores to assign labels to your output. You have to make a call. More precise model will have a low recall, and a high recall model will be less precise. Fortunately, however, there are some heuristics which allow us to determine which machine learning model works well for us. Two of these heuristics are here: the F1 score. The F1 score is the harmonic mean of precision and recall, and then we have the ROC curve. The ROC curve, or the receiver operator characteristic curve, is one which we get when we plot the true positives versus the false positives. The idea is to find that point on the curve which maximizes true positives and minimizes false positives. We start off by considering the F1 score. The F1 score is the harmonic mean between precision and recall. The harmonic mean is a kind of average which is typically used when we have rates to consider. It's the average of rates, and precision and recall are both rates. The harmonic mean formula is as shown on screen: 2 multiplied by precision multiplied by recall in the numerator, precision plus recall in the denominator. A standard characteristic of the harmonic mean is that it's often closer to the lower of the two factors that go into it. It will be closer to the lower of precision and recall. The advantage of using the harmonic mean, or the F1 score, to evaluate our machine learning model is that it gives us a very even trade off between precision and recall. So, if your model is not so specific such that it requires a high recall or a high precision where it favors one of the metrics over the other, using the harmonic mean is a good option. The F1 score gives you a single number which allows you to evaluate your machine learning model. The single number represents how good your algorithm is. So, how would you compute the model which has the best F1 score? Now, you'll follow a process that is very similar to hyperparameter tuning that we've spoken of earlier. If you remember, precision and recall values can be tweaked by changing the probability threshold, the decision threshold for our classifier algorithms. What you'll do is you'll run a bunch of training data with different machine learning models where every model has a different decision threshold. The decision threshold can vary from very conservative to less conservative. For every training run with a certain decision threshold, you'll find values for both precision and recall, because precision and recall are what are used to calculate the F1 score, the harmonic mean. Apply the formula for the F1 score to the precision and recall values that we've calculated for every training run. Precision and recall value will be different for every training run because we've changed our decision threshold. With F1 scores available for all the machine learning models that you've generated, you'll choose that model which has the highest F1 score. That is the better model. That is the one which offers the best trade off between precision and recall. Using the F1 score to choose a good model was pretty straightforward. Let's see what the ROC curve is and how we would use it to get a good classifier model. The ROC curve plots the true positive rate of your machine learning model against the false positive rate. The true positive rate is plotted on the y axis, and the false positive rate is plotted on the x axis. Of all the positive cancer predictions that our machine learning model made, the true positive rate is the fraction that were actually correct, where the actual label was equal to the predicted label. The false positive rate was the remaining, the fraction that our machine learning model got wrong when it predicted cancer. Intuitively, in a good machine learning model, the true positive rate should be as high as possible. If the machine learning model detects cancer, the person should actually have cancer, and that number needs to be maximized. On the other hand, the false positive rate should be as low as possible. If the machine learning model says there is cancer, there should be very few instances that cancer does not exist. This plot of the true positive rate versus the false positive rate is the ROC curve, or the receiver operating characteristic curve. And this is the curve that we'll use to choose our threshold value for decision making. Remember that this is the decision threshold that will determine what the predicted label of our machine learning model will be. As we did before, while calculating F1 scores, you'll vary the P threshold for your machine learning model. This is basically akin to hyperparameter tuning, and you'll plot the true positive rate versus the false positive rate for all of the models that you generate. This plot of the true positive rate against the false positive rate as you vary your decision threshold follows a very typical curve, similar to the curve that you see on screen. You'll find that models which have a low true positive rate will also have a low false positive rate. As you try to increase your true positive rate, the false positive rate will also increase. And once you fit a receiver operating characteristic curve across all of these points, you have your ROC curve from where you'll make your choice of a decision threshold. Once you have this curve, you'll choose that model that has its P threshold at the top left corner. Pick that model with its P threshold here so that you maximize the true positive rate and minimize the false positive rate. The top left is what achieves this. If you have the perfect classifier where the true positive rate is at 100% and the false positive rate is at 0%, you'll basically find that the decision threshold is at the top left on the true positive rate axis. The ROC curve is basically the y axis itself. If you were to plot the ROC curve of a random classifier, which basically picks cancer or no cancer completely at random and has a 50% chance of getting it right, you'll find that the ROC curve, where true positive rate is equal to false positive rate, is at an angle of 45 degrees. Two common heuristics that you can use in order to choose a machine learning model that fits well and it optimizes the precision and recall, maximizes true positive rates and minimizes false positives are the F1 score and the ROC curve. The F1 score is the harmonic mean of precision and recall, and it tends towards the lower of the two. It gives you an even trade off between precision and recall. The ROC curve, the receiver operating characteristic curve, on the other hand, plots the true positive rate of your model with its false positive rate and tries to find that value of decision threshold where your true positive rate is maximized and your false positives are minimized.